Cool, 15 kV. Very nice. Okay. So definitely confirmed, trustable verifying, very important words in this industry. So 15 kV then. So taking a look at our test form. Right?
Thanks, Rudy.
We're going to say our test kV. Building up our test form, right? Yeah. So that's 28,800 volts. Sound like a lot?
Yes. Hey, you left. It was way more lecture, but I have a video.
So
When you left.
we know there's gonna be a lot of big hazard involved,
Well,
right?
he told me
Goes
that
without
they
saying.
have it in the, on
And
the
so
slides.
we're gonna make
Oh,
sure
yeah,
that
yeah.
we try to do appropriate caution for that.
Okay.
Let's take a look at our test set. It's gonna look something like this. A little bit different. This is a slightly different model, but has the same components, same constituents. And so I'll draw just attention to our DC milliamperes. So definitely we're sure that this is not a high current we're going for. So just like with our other test sets, what are the control variables? What's under our power, right, to actually change in our test sets, right? Well, how about this guy, right? So we, as the operators, as the qualified electrical technicians, right, we get to select the volts that we actually ramp this up to, right? And so that's going to be in our top right corner here. Oh, cool, look at that. So, what does this say here? Okay, so this is AC. Cool, all right. In this case, if we're going to 28.8, whereabouts would you say? But yeah, if you're on the lower scale, you have the voltmeter here set to high or low here. If you're going to 28.8, you probably remain on the low scale, right? And you go somewhere above the 8 tick mark right here, so 5, 6, 7, 8, but just below 9. Obviously, you're only eyeballing at any point between those analog tick marks, right? So maybe shooting for about the 29 mark, right? And again, best practice would be, hey, does it withstand for 1 minute?
Since we did DC, would that affect, can we still use that one even though it says AC?
Yeah, you're exactly right in thinking that we need to consult once again our chart here, right? So what would that mean if we were using the AC? AC test?
There we use 20.4.
20.4. So in this case, and we'll double check, again, trust will verify, but I believe our test is going to be DC, so we'll use that accordingly. But if it is AC, definitely we're going to consult the chart and then actually end up with that lower kV there. Okay? So good call. You could use the high scale, but then your resolution only goes down from there, because then you're really eyeballing, if this is 30 here, then even the best resolution you get is 28 on this previous. So chances are, to be more precise, you're going to stick with the high scale. Okay. What other things are you seeing on here? Anything of interest? Here?
Ground and guard.
You're definitely going to apply the ground. I heard ground safety first. We're going to apply the ground.
Also the ground and guard.
Yeah. So current range, we have here AC milliamperes. Right? So keep in mind, there's going to be a current range multiplier of 1, 10, or 100. It's kind of hard to see here, but this says 0.2, 0.4, 0.6, 0.8, and 1. Right? So keep in mind that depending on your multiplier, right now it's set to 10. So if the needle was, say, here, what is the actual value that you would record on your test form? It would be 0.2 times 10, which is 2.
Oh, correct.
So you would take this number, and depending on the multiplier, you have to multiply that out, and that is what would go in your test form, I believe. You can see that on your test form. We'll actually call out what your leakage current is. Well, let me skip real quick.